Hi guys, hope everything's going okay and you were all safe. Just starting a new topic today on network systems. Just going over some fundamental content here that you're going to need going forward, especially when it comes to your sort of second assignment and implementing this practically um, into a physical system. Okay, so let's just start with some definitions just so we're all clear. Hopefully, you've been over this in other units, especially the exam units. So, a MAC address is a physical address that hard coded into a network interface card. So, every device we have that's got internet access or network capabilities, a phone has a MAC address. Your motherboard on a desktop will have a MAC address. A Wi-Fi card has a MAC address. So that's important to know that if you've got a Wi-Fi card and a LAN connection, you will have two separate MAC addresses for that machine because they might come from different manufacturers. So you might have a sort of an Intel Wi-Fi card and a gigabyte motherboard, and them two network interface cards as such will have different MAC addresses. So if you're accessing the network wirelessly or wired, so it can be identified through the right protocol. So remember that it's the physical address, and it's hard coded from the manufacturers themselves when they physically make the card. And you've got an IP address, which is a logical address, which identifies a device on a network. It's key to understand the differences there. So what's commonly used as sort of an analogy is a postal system. So you as yourself, your name is the MAC address. So if your name's Ben, that's the equivalent of a MAC address. Now your address, if you live at Burnley College, then that's your sort of IP address because that can change as you move around. However, your name doesn't change. So if you move from different networks, your name doesn't change, but your sort of IP address will, because as you're changing from network to network. Okay, so it's really important that you can sort of distinguish between the two. So how do you find your IP address? If you go on a Windows-based machine, if you go to command prompt and type in ipconfig/all, that will then give you all the information you need, which is a common sort of command line to use in a networking career at any level, starting from the very sort of beginner level network engineer right up into the top, because if this information isn't showing, then it'll be clear that you've got a problem on the network somewhere. So highlighted in yellow on this screenshot, you've got a physical address, which is what a MAC address looks like, and you've got the IP version 4 address here, the default gateway, which is usually the router that you're going through on that network, the DHCP server, which is the server that's providing the IP addresses to each device, and then your DNS server, which converts the numerical data into text form. So it'll change the IP address into a more readable URL, so like google.com or burnley.ac.uk. So we'll go into more detail about them servers later on. But for now, it's just important that you know what an IP address looks like, you know what a MAC address looks like. You can distinguish between a MAC address and an IP address. Okay, so a good question to ask at this point is where does this IP address come from? So within any network, IP addresses are sort of given out by a server. Now that it can be done at home by a router, or it can be done on large networks from a dedicated DHCP server. Okay, so the difference between a server and a client is a server that gives out resources, and a client takes resources. So that's sort of what this image is doing. The client's requesting an IP address from the server, and the server's giving out that IP address. So every time when you come into college, you will be given an IP address. Depending on how that's configured, is up to the network management team. And now on large networks, it's usually you have a guest network where you would have a lease time of approximately 1 day, so that every time someone comes into the network with a new device, they will need to register that device with various credentials, and then that IP address will go back into a pool a day later. So lease times are important. It depends, like I say, it depends on how the network manager wants to work it. It's common that it could be 1 day, it could be 7 days, it could be 15 days, just depending on how many IP addresses are available. But in like I say, in large networks, it's more common to be a day, because you want them IP addresses back in the pool to be given out to other devices, so you don't run out. Okay, so this is sort of the key topic for this week. What we need to grasp is the different classes of IP addresses. So IP ranges are broken down into 5 classes. You've got Class A, Class B, Class C, Class D, and Class E. Most courses now right up until sort of level 5, cybersecurity, networking, games development has elements of networking, just focus on Class A, B, and C. So that's just what we will focus on. So the range for a Class A is 1 to 127.255.255.255, and Class B is 128.0.0.0 to 191.255.255.255, and then Class C is 192.0.0.0 to 223.255.255.255. So you'll notice at home, if you've done your sort of IP config, that it's more than likely you're going to be on that Class C network. And in college, we've done this activity a couple of times. You should have noticed, or you should have identified that we work on a Class B network at college, or we have a Class B network in college, and that will all explain itself very shortly. Okay, so if a network address, an IP address is 32 bits. So as you can see from this sort of lower diagram, it's split into 4 bytes. So you've got 8 bits within each number. So for a Class A, the first byte is where the network addresses are. So they'll be network devices, and then the last 3 bytes are available for hosts. So anyone coming onto the network will be given an IP address in them last 3 bytes. So just jump into this Class C in your home network. You've got sort of a 192.168.0.1 more than likely for your home network. So if you look at all your different people, family members, friends who come onto your network at home, they'll be given an IP address where the last number is going up all the time. Okay, so it'll be going from 1, 2, 3, 4, 5, 6, 7, 8 right up until to 255 on that last column only. Whereas at college, because we're on a Class B network, because we're in this 172 category, or 176, off the top of my head, I can't remember which exact IP address they start with, but our IP addresses when we're coming in the building will be going up in this 3rd column because it's a Class B. Okay, so why this is important, it's going to all start making sense very shortly. So just remember, home network, small, the final column's going up because it's a Class C. A Class B in college, the third number will be going up as people are joining the network all the time. Okay, so just going back a second, sort of, if you wrote out an IP address, you'd have 32 ones or zeros in full. Okay, so we always start from the right-hand side. So for a Class C network at the top, you'd have a maximum of 2. Well, let's just keep it simple for now. You'd have a maximum of 255 available IP addresses, because from right to left, if we go up in sort of IP range form, and it's sort of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay, so we're sort of doubling all the time, and we add all them numbers up, it gets to 255. If we do the same for class B, if you look in this section here, where we carry on, so it'd be 2 to the power of 8 for the sort of next bit, and then 2 to the power of 9, 2 to the power of 10, and so on. So if you times all them up together, you will get a maximum number of 65,534 hosts available. Okay, so at home, at home you will have a maximum amount of people can join your network. Will be 254. So it's not 255 because you can't have the router. So you've got 255 total, but the router will take 1, and then all the other people who join your network, all your family members, hopefully you don't have any wild parties where you have all this amount of people. But if you did, that's how many people would be able to join that network, or devices would be able to join that network. So if you have more than that in your home, or more than that many devices, which is if you're really rich and you have all them phones, then fair enough, but you will run out of IP addresses and it causes you a problem. So that's why at college we run off the Class B network. So we've got a potential total of 65,000 IP, 534 IP addresses available. Okay, so we don't use a Class C at college because we would simply run out, because there's more students than that, and more devices than that as well in college. Okay, so this is important. So how this is going to sort of work for your assignments is you're going to have to sort of implement an IP address range for a given scenario. Okay, so you'd have to sort of discuss why, and how you're going to implement your IP range. Okay, so hopefully that's all made sense. I won't be in until next week. However, there is a knowledge check on Google Classroom for you just on today's content. And like I say, we will be implementing this in a practical sense when and if we get back to college, and sort of next week, just because we'll still be sort of in the situation we're in. We'll just sort of work on some more activities to build our sort of second assignment up, and just make it a bit more easier going forward. So when we do come back to college, it's just going to be about doing practical work, sort of till the end of the year. Okay, so I hope you're all well. Feel free to send me a message if you've got any questions, and I will get back to you as soon as I can. See ya.